Read this one first in here. How to convert angle measures from yeah, definitely from radians to degree measure. All right. So let us have our given in here first. The following. Okay. So it says what's that? Negative 5 pi over 4. Right? So how many degrees will that be? All right, let's read our step number 1 in here. Kendall, go ahead, please.
Multiplied by pi over 180 degrees or 180 degrees over pi. One circumference of a unit circle, r equals 1. Circumference equals 2 pi, r equals 2 pi radians.
Thank you. All right, so as you may notice in here, you talk of radians as what? As the part of the circumference of a unit circle, meaning radius equals 1. In this case, if you talk about the whole circle, well, the circumference of that one is 2 pi r. Since r is 1, then that means one full circle is 2 pi radians. Right? So think of radians as a circumference of the unit circle with radius 1. Okay? I think it's redundant already. When you say unit circle, automatic radius 1. Cool. Okay. The angle, however, is the angle that comes from the center, right? What we call the central angle. So one full rotation is 360 degrees. Be cool. So if we can equate those two, then we can say that what? 2 pi radians is equal to 360 degrees. But since both are even numbers, so you can just both divide by 2, hence pi radians is equal to 180 degrees. And that's where those two came from. Okay? So, radians can be simplified fraction form. So for example in here, negative 5 pi over 4 radians, how many degrees will that be? So basically, just multiply this by what? There we go. 180 degrees on top. Very good, right? And pi radians below. So as you may notice, the radians in here and there will cancel out, right? That's how you would know, obviously, is it the pi over 180 or 180 over pi, right? So whichever one you need to cancel, that should be below, okay? And whichever unit you need to remain in there, the degrees will be the one on top. Okay, so top remains, the bottom cancels out, right? So in this case, that is in degrees, and what's that gonna be? The pi's in here will cancel out, there we go. Or you can just basically use your calculators for such and do that one, right? 180 times negative 5/4, okay? So let's use our decimals for that. Again, we have already canceled the pi's, so just click in here and put the following, all right? 180 over pi, and this one is negative 5 pi over 4. There we go. Right? As you may notice, it gives us negative 225. Right? You can copy it like that. By the way, in decimals, the pi, you can click in here and get pi, right? Or just type in pi. It will automatically give you the pi for such. Okay? So how much is that? Negative 225 degrees. Are we good? Oh, let's try this one. What if we have the following? Okay, so how many radians are there in 172 degrees? Okay. So basically in here, you want to cancel the degrees, right? So that means the degrees should be below. And the radians is the one that you want to remain in there, right? That's the one on top, so that means what? Pi radians, 180 degrees. Cool. So the degrees will cancel out. Okay. And consider your answer for such, right? So typically in here, if it's in radians, the pi will remain, and simply simplify or just get the simplified form of that fraction, right? What's 172 over 180, right? Let's put it in here. 172 over 180 in our calculator. Let's see what we're gonna get out of it, okay? Okay, so here's the deal. We typically don't get the decimal, not unless it's mentioned. It's rare, right? The common in here is to click on this blue button to get its fraction equivalent. Are we good? Right? So the fraction equivalent of 172 over 180 is 43 over 45. As you notice, I did not put in the pi anymore because the pi is already in here, right? So I'm just gonna put in here what? What's that? 43 over 45 pi. Are we good, guys? Right? If you want to see on our decimals calculator where the degrees and the radian measures are at, we can click in here. Oh, sorry, not in here. We can click in here on the upper right-hand corner, graph settings. Okay. Now, if you notice in here, you have the polar coordinates, right? So you click on that polar coordinate or polar grid. Here it is. If you click on radians, you would see in here the radian measures, right? So that's 0, 1/6 pi, say 7 pi over 6 radians, 5 pi over 3 radians, and so on. We good? Right. So where's that 43 over 45? So basically it's somewhere here, right? Because 43 over 45 is less than 1. Good? Right. The degrees, where's the degree equivalence for such, right? So if we go in here and click on degrees, and you're gonna see this one now, the degree measurements, right? Good. So that's 0 degrees, 60 degrees, 180 degrees. A while ago, 172 degrees is somewhere in here, right? Cool. Right? And so on. Are we good? Right. So once again, we are using, if you go to graph settings and want to visualize where we are at, click on that polar coordinates and check if it's radians or degrees that you want to see in there. Are we good? Okay. Now, let's go to coterminal angles. Any question regarding the radians and degree conversion? Let's see about coterminal angles, and let's read this question in here. Okay? Okay, let's read this question in here. Go ahead, please.
For the following exercises, find the angle between 0 degrees and 360 degrees that is coterminal to the given angle.
To the given angle. Let's okay, choose a number. 50, 51, or 52? Doesn't make it matter. 51. All right, let's try that number 51. 110 degrees, right? So, negative, right? Negative, oops. Negative 110 degrees. Find its what? Standard angle, right? Equivalent, right? So what is the standard angle equivalent for that? Well, first of all, how do we know if it's coterminal angle? Let's read step number 1. Okay, Jeremy, go ahead, please.
Notice that a terminal angle are less than
Greater than
greater than 2 pi
radians. Yeah.
radians 360 or negative.
All right. So as long as it's negative like this, or more than 360 degrees, right, or 2 pi in radians, then it is coterminal. We good? Right. Now, so check. We know this is a coterminal angle. Well, what do we do then if it's a coterminal angle? Right? Let's read step number 1. Go ahead.
Add or subtract 2 pi multiples or 360 multiples such that it will result to 0 less than, or what's that?
This is a theta. Yeah, it's our Greek letter theta.
Less than 2 pi.
Thank you, right? So you want to add or subtract a multiple of what? 360, right? 4 degrees, or 2 pi in radians, right? So that it will go what? Positive less than 360. Are we cool? Right. So with this, what do? Do we add or subtract to make it positive less than 360?
You add.
Add, right? Very good. So let's add what's in here. 360 to this. What's gonna happen if we add 360, right? So add 360 degrees. Okay, what's that gonna be? Negative 110 plus 360.
250.
Huh?
250.
250. Right? Now, is that resulting theta? Is that between 0 and 360 already? Yes, right? It is positive, it's less than 360, right? So check, this is already in what we call the standard angle form, right? As long as it's between 0 and 364 degrees, or 0 and 2 pi for radians, then we got the standard angle. Are we good? Okay, next. Let's read step number 2. In short, like how to visualize, all right? Go ahead, step 2.
To draw the angle, the number of multiples will be the number of full rotations.
Thank you, all right? So the number of multiples in there is the number of full rotations for such, right? So for that negative 110 degrees, here it is. Well, that's negative, right? So when you say negative, then that's gonna be what?
Clockwise.
Clockwise, right? From the positive x-axis, very good, that is correct. 110, right? So from here to here, that is negative 90 degrees, all right? So how many more angles? 30 degrees more, right? Okay. Good. Oh, is that 30 degrees more? 20 degrees more, right? 20 degrees more. So by angle addition, if you add all of these, then that's gonna be what? Negative, what's this? 110 degrees. You good? Okay. Where is the coterminal? Where's that standard angle? Where your standard angle in here now is 250 degrees, right? So that means from here, oops. Which one? Okay, this one, blue, right? So where's the standard angle? You good? Right. So standard angle, that is how much? 250 degrees. So this is the standard angle. Less than 360, positive. And this is the what? In green. Coterminal angle. Okay, right? So as you may notice, they have the same, this is what we call the initial side. And they also have the same, what we call the terminal side. Right? So again, let's just put in some terms in here. This is the initial side, and this is the terminal side. Right? And that basically is the definition of coterminal angles. Are we good?
Yeah.
Questions with coterminal angle?
What is it that we were looking for by doing this?
In here, we talk about what is this? Find the angle between 0 and 360 that is coterminal to the given angle. So in short, the angle, that is what? When you say an angle that is between 0 and 360, that is a what? Standard angle. Right? So, because for it to be standard, it has to be what? From 0 to 360, right? Anything that is positive but less than 360 degrees. Good. Some cases, you are given the standard angle, you have to get the coterminal angles for such. And this limitless in there. So you either add some multiples of 360, what else? 720, right? What else? Plus another 360. 1080, and so on. We good? Or subtract. Questions? Let's talk about reference angle, right? Let's talk about reference angle in here and see what we can get from this one, all right? So let's talk about this. Okay, so we are given negative 17 pi over 3 radians. Okay, what will be the reference angle for such? Okay, so that's our example for such. You've got negative 17 pi over 3 radians. What will be the reference angle for such? We good? Right. So let's read our step number 1 for such and see how we can work on it. Okay. Oh, step number 1. Let's read that one and one. Listen, go ahead.
Make sure you give an angle to the standard form.
Right. So that means when you say standard from 0 to 360 or from 0 to 2 pi, right? So what do you do once again for coterminal angles? Either you add or subtract a multiple of 360 or 2 pi, right? So in here, that's what we're going to do in here, right? So you want it positive, right? So you add. So what's the best multiple of 360 that we can, 2 pi, to think about for this? Is it 2 pi, 4 pi, 6 pi? What do you think? Well, the nearest, right?
6 pi?
6 pi? Let's try 6 pi, all right? 6 pi radians, okay? So you know what? Let's just use a calculator for such, right? Since we have a calculator, we don't need to worry that much if that is in fraction. Just don't worry about the pi. Let's just focus on the numbers, all right? Put in here. Negative 17 thirds plus 6. You good? Click on fraction, that blue button. It gave us an answer right away, right? So negative 17 thirds plus 6, it's going to give us 1/3 pi. Are we good? Right. So with that being said, put in here, this is what? Pi over 3 radians, right? Now, is step 1 already done? Is it positive less than 2 pi or 360? Yes, it is, right? Are we good? Next one, step number 2, right? Let's read step number 2. Cecilia, go ahead.
Determine its quadrant location.
Thank you, right? So we can use our decimals for such. So this is in radians, right? Just use the radians in here and see from here, right? Okay. So where is 1/3 pi? Is it in quadrant 1? Okay. Quadrant 2, 3, or 4, all right? So just put some notations in here for everyone's like visuals in here. So this is quadrant 1, as you may notice, from 0 to what? Pi over 2 radians, right? Good. For quadrant 2, that is from what? From pi over 2 to what? Pi radians, right? Quadrant 3, that is pi radians to 3 pi over 2 radians, okay? Or 3 halves pi. And this one is from 3 halves to 2 pi radians. That's quadrant 4. And again, don't worry about fractions, guys, because decimals, it's always going to convert whatever decimal equivalent you're getting. Always just click on that blue button. It's going to convert it automatically into fraction. Okay? Like, Mr. Ding, I really cannot get these fraction things, right? Always just click on that. It will convert your decimals into fraction right away. Are we good? All right, let's go back in here. So what is its quadrant location? Pi over 3. First quadrant. Very good, right? So put in here, quadrant 1. So according to this one, step 3. Let's read this step number 3, all right? Go ahead, miss. Reference angle.
The reference angle. What's that?
Theta given.
Theta given quadrant 1.
Yeah, so for quadrant 1, it's just the given theta, right? Continue, please.
Pi root theta
Yeah, pi minus theta, right?
is quadrant 2.
For quadrant 2, you subtract the pi to the angle given, right? For quadrant 3, go ahead.
Theta minus
Yeah, so the given angle minus pi, right? And the last one, quadrant 4.
2 pi minus theta.
Thank you, right? Quadrant 4, 2 pi minus the given angle. Since this one is in quadrant 1, what do? Just copy it, right? Good. So the reference angle, is equal to, or theta reference angle is equal to pi over 3 radians. Good, right? Step number 4, if we need to visualize how it does look like, okay? Step number 4, let's read that one in there. Sir, at the back, draw.
Draw the reference angle on the x-axis.
Thank you, right? So where's that reference angle along the x-axis, right? So if I draw it in here, let me just use a different color, okay? Let's just use a highlighter for such, just to make it like, really emphasize it. Good. So since this is in quadrant 1, it's nearest the positive x-axis. We good? Okay. As you may notice, pi over 3 is already in here anyways, right? Good. So this angle in here, okay, actually from x-axis to there, that's your, what do you call this? Theta reference angle. Are we good? Right. Where is, by the way, the negative 17 pi over 3? That's a good question. Where is that negative 17 pi over 3? Well, it's in here. Ready? Okay. So from here to here, that's 2 pi, right? Okay. Or actually negative 2 pi, right? 1 full rotation. From here to here, what's that? Another negative 2 pi, so that's negative 4 pi, right? We good? Okay. So how many of those? Negative 2 pi. Okay, negative 6 over 3, right? We good? Negative 12. Oh wait, negative 6 over 3. That's correct. After negative 6 over 3 is what? Negative 12 over 3, right? Good. So that's negative 12 over 3. How many more? Negative 5 pi over 3, right? So from here, let's count. Negative 1, negative 2, negative 3, negative 4, negative 5. All right, there we go. Right? That is our what? Negative 17 pi over 3. You know what? Let me use this big one here. This is your what? Negative 17 pi over 3. Negative 2, negative 4. That is negative 17 pi over 3. Right? And this one in here is the reference angle for such. Equivalent to, how much is this one in blue? Pi over 3. Are we good? Right. So check on the definitions for such. Once again, we can say that the reference angle is defined as what? It's acute angle reference to the x-axis, right? Whether that be the x-axis, positive x-axis, or negative x-axis, whichever it is nearest. Are we good? Thank you.